welcome to my channel. In this video we are going to talk about RO, reverse osmosis based water purifier. You can think of this video as a tutorial which covers almost everything about the RO at a high level. So let us start with the pipes and the connectors. This pipe is 3/4 inch in the diameter, and the pipe specification, the size is constant irrespective of the brand. Whichever RO you have, the size is same, and the white one is used for the pure water to pass it from one filter to another filter and ultimately to the RO tank, and blue one is used for the impure water for the waste line. Okay, the size of both of them is same. You can use any one for any purpose, but as a good practice, the white one is used for the pure water, the blue one is used for the impure water. Now if you want to cut the pipe, the cutting is very simple. You have to use a cutter like this. With the help of this cutter you can easily cut it. Ideally you should place the pipe on the ground and then put the knife on it, the cutter on it, and slide the cutter on the pipe. See, so these are very soft and easy to cut actually. Now let us talk about connectors. See, mainly there are only two type of connectors available. One is plug and play, and this one you see it's a threading type. So if you are having a threading type for a use case, for a particular use case, then you have to put a Teflon tape and then fix it. Otherwise, if it is like this, then it is just a plug and play. Let me show you. Put the pipe here and push it inside till you hear a click noise or till you reach the dead end. It is leak proof, leak free. There is no leak at all. Okay, and if you want to pull it, it will not come out. It is a permanent locking. So if you want to take out the pipe, what you have to do, this ring you see, this ring you have to push it back towards the connector like this, and now only you can pull the pipe out. Now let us see one more thing. It's a little thing, it is called lock. See, if you want to take out this pipe, what you have to do, this ring you have to push it back towards the connector and then pull the pipe out. If you want to avoid this happening accidentally, then you can lock it like this. Before this ring I will place this lock like this. Now if it is done, then what happens, we can't push the ring towards the connector, and if that cannot be done, the pipe will not come out. Okay, so this is kind of an additional safety which I never use. Okay, so anyhow this is leak proof, leak free, permanent locking. If I want to pull the pipe out, what I will do, push the ring back towards the connector. Now pull the pipe out. Simple. See how we are going to connect all these filters. It's very simple. It's just a plug and play. So this is the connector. Place it here one side. Other side you have to put the pipe. So it's just a demo. So these two pipes are right now connected. If you want to disconnect, how you will do, simply same logic. On this connector there is a ring, so you will push that ring down and then pull the pipe out. So ring down, pull the pipe out. Similarly for this side, ring down, pull the pipe. Now how we will remove the connector, because that ring you can't reach, so you have to use a screwdriver like this, and it's very simple. Just try to place it below the ring and then pull it up. Let us see two more things, this metal thing and this wall. So this is called RO nipple. If you want to provide the input supply, the water supply to the RO, then the extension is taken via the RO nipple. So you'll place the RO nipple in the existing line, and then this wall you will place here. There is a hole here, you can see. So here you will put this wall. From here you will take the input for the RO, and there is a wall also. You can close it for maintaining the RO. You can see the RO nipple and the wall. Now let's talk about this pre-filter. This plastic box this and this cap, this is called the housing for the pre-filter. This is a pre-filter, it's a spun type pre-filter. Before water goes into the RO, it passes through this pre-filter. The tap water goes into the pre-filter, it gets filtered, anything above 5 micron is filtered out, so it's very important, and then the filter water goes into the RO for further filtration. So this is the kitchen RO, and this is the normal tap water. This is going into the pre-filter and output is going into the RO, and this is the exit line. Okay, so the tap water input goes into the pre-filter and the output of the pre-filter goes into the RO. Okay, now another important point in the RO maintenance is the TDS meter. Now with the help of this device, within few seconds you can find out the impurity levels in the water, so you can check the TDS level of the tap water, of the RO output water, and with the help of this you can find out when to replace the filters. If the TDS levels are increasing in the RO output water, that means it's a time to replace the filters. See, this will measure only the TDS, total dissolved solids, which is actually just the minerals, the amount of minerals present in the water. For example, if you buy the Bisleri water from the market, the pure water, the TDS would be in the range of 60 to 65 ppm. Okay, if you check the municipal water, the government water supply, depending on the area, city, the TDS would be in the range of 100 to 200 ppm. If you measure the groundwater, usually it is above 500, 600, 700, it can be 1000 to 1200 also ppm. See, up to 400 also TDS is okay, it is drinkable, it is usable, but the problem is we don't know the quality of the mineral. See, this will not measure the quality of the mineral, it will only measure the quantity of the mineral in the water. Because we don't know the quality of the minerals present in the water, it is better to have as low TDS as possible. I recommend below 100 is safer. Okay, for example, with the help of this device, if you measure the coconut water TDS, you will see it falls above 4000. If it is orange water or watermelon, it can be above 5000 and up to 10,000 also. But we know those are natural food, organic minerals, and our body can easily absorb them, so those are safer. But in the case of water, because we don't know what kind of minerals are there, whether they are good for body or not, whether they are organic or not, whether our body can handle them or not, so it is good to have as low TDS as possible. So below 100 is what I recommend, what I prefer for my home also. And whatever minerals which are missing, you can compensate from different sources by fruits, fruit juices, and other sources. Okay, so here we have to fill the water and then measure with the help of this one. Inside this you can see there are two nodes. Okay, so if the minerals are higher, then the current will pass faster between these two nodes, so that's a mechanism. So what we are going to do, we'll on it. So right now you can see it is showing 0 ppm. Now this is the tap water. You can see 682 ppm. Now I will use the drinking water, the RO output. Small quantity is okay. So right now it is 0. So it coming to 43. 42, 43, that means absolutely safe. Now let us quickly understand the flow of water. So the tap water goes into the pre-filter, this stays outside of the RO. Okay, output of the pre-filter goes into the RO. When I say it goes into the RO, that means it goes directly into the very first filter, which is the sediment filter. This is the flow direction. Input comes from here, output goes from here. Output of sediment filter goes into the carbon filter. This is carbon filter. Output of the carbon filter goes into the SV. This is called SV, solenoid valve. Okay, functionality we'll discuss later if the time permits in the video, because length is increasing. Output of the SV goes into the machine, this motor. This is called booster pump. Output of the booster pump goes into the RO. This is the real RO. This is what we refer as a RO, reverse osmosis. This is the main filter, heart of the RO. Okay, this is where the TDS is reduced to a significant level. This is the most important filter inside the RO. Now this has two output. This is the input and it has two output. The bottom one is the pure water, this is the wastewater. So this is the blue line, this is a white line. So output of this one goes into the mineral filter. This is mineral filter. Output of mineral filter goes into the UF filter. Okay, and output of the UF filter, this is the direction, goes into the tank where it gets stored, and then we can open the tap and drink and use the pure water. So this is the high level flow I explained you. There are few more filters depending on the brand that you buy, and the stages of the filtration. There can be few more filters. If you count the stages, stage 1 pre-filter, 2, 3, 4, 5, 6. So we can call this RO as a 6-stage filtration RO. If you have few more filters, then filtration level will increase. Okay, now let's talk about these filters, mainly the RO membrane. See, other filters you can understand the use case of them on the Google. See, the sediment, as the name suggests, it will filter out the sand, silt, clay, any bigger particles. This is carbon filter. So these are charged carbon. This is to filter out the chemicals. This is mineral filter. RO membrane removes some of the essential minerals from the water. So this is to add the additional mineral to the water. This is UF filter to remove the contamination, bacteria and virus. Okay, in your RO you can have few more filters like UV filter, ultraviolet one, to kill the bacteria, and like copper filters becoming very famous these days, alkaline filter. See, this RO membrane, the output of the RO is usually acidic. To make it alkaline, there is an alkaline filter also these days. So depending on the filtration stages you have in your RO, or the brand that you have, or the model that you have, you can have more number of filters. Okay, see, the main filter in the RO is this one, the RO filter. This is RO membrane, because this is where the TDS is reduced significantly. Major impurities are removed at this stage only. Okay, others are just supplementary ones. Now how this functions, see, first of all, this is the housing. So this membrane you will place inside the housing. Okay, like this. So this is alignment, these are the washers here, and inside also there are few washers provided. Okay, now these are the connectors. They come with the kit when you buy this. So you have to put the Teflon tape on these threads and fix it here. Similarly on the top also, this is input, these are two outputs. This is the pure water, this is impure water. So here you will fix the white line, white pipe, here you will fix the blue pipe. And to function this RO membrane, it requires huge pressure. That's why the output of the booster pump directly goes into the RO housing, because it requires more pressure. See, this is designed in such a way, you can see these channels. So it works only on the pressure. When there is a huge pressure, these channels expand and it will allow the pure water to pass. All the bigger particles, impurities will come from here, and the pure water will come from here. This is how it functions. So it works based on the pressure. Okay, other filters don't require any pressure, they work on the normal tap water pressure, but this requires extra pressure to function. That's why the input of the booster pump goes into the RO. Okay, now there is one more thing. This is called flow restrictor. So this is waste line, as I told you, impure water. So here you have to fix this flow restrictor also. Now why there is a flow restrictor? This is actually to restrict the flow, to hamper the flow of the water. Otherwise most of the water will go only from the waste line. We have to place a flow restrictor. So you will put the connector here, some pipe here, blue pipe, and then there will be a flow restrictor. Then the output of the flow restrictor will go directly outside of the RO via the blue line. Okay, this will restrict the flow By restricting the exit flow, it will allow the more pressure to build inside. That is the responsibility of the flow restrictor. So depending on the RO, when you're buying the RO housing and the membrane, you will get the flow restrictor also. Even in the annual service kit which you buy for your RO, you will get the flow restrictor also. If you don't get a flow restrictor when you're buying the RO housing and the membrane, existing flow restrictor in your RO, if you have, then you can reuse that. So this is placed on the waistline. Now this blue guy, this is SV, solenoid valve. So this is kind of an electromagnetic switch for the water supply. See, there are 2 points, input and output, water line. Water can pass only when this switch is on. Just like, electric switch, like if you want to turn on the fan, so you will toggle a button, on off. Similarly, this is also a switch for the water. When it is on, it will allow the water to pass. When it is off, it will not allow the water to pass. Okay, now this is the toggle point. So this, you see, this whole set, this will sit on this tank, RO tank. So when the water level reduces, when you're dispensing the water level will reduce, and this guy is hanging on this tank, RO tank. Because the water level reduces, it will hang, and then it will toggle. When it toggles, it will turn on the supply to SV. SV will turn on, and it will allow the water to pass. Okay, when the water level again fills, it reaches to the limit, then again it toggles, and then it will cut the water supply, electric supply and the water supply. So like this, you see. So this is how RO functions automatically. By the way, in this whole RO, this pre-filters and all these filters, including this RO filter, this is RO housing and this is RO membrane, they don't require electricity. Electricity is required only for the booster pump. Okay, to the booster pump and to the SV. And there is one more filter which requires electricity, that is called UV filter. In this RO, I don't have the UV filter. Actually, it was there, it was not functioning, so I removed it. It's not very important in my understanding for my use case. Okay, so the UV filter is the only filter which requires electricity. Otherwise all these filters are manual. This guy is also manual, but it requires a lot of pressure to function. Okay, and that pressure is created by this booster pump. Otherwise carbon filter, sediment filter, mineral filters, alkaline filters, UF filter, they don't require any electricity. They have only input and output points. Okay, now about assembling, putting all these filters together inside the RO, that I cannot demo because length of the video is already increasing. So I'll just share the high level what needs to be done. It's actually very simple. So you see these clamps, these are to hold the candles, like these candles. So the input water, the input to the RO will go to the first candle. This is the line, you see, this is coming from outside. So this line will go into the first candle, which is the sediment one. So sediment I will keep here on this clamp. Okay, output of sediment will go into the carbon, so carbon I will keep here. Then output of the carbon will go into the SV, so I'll make a connection here with this these pipes. Okay, output of the SV is going to the motor, so that pipe is already there, this pipe. Output of the booster pump will go into the RO, so I'll make that connection. Like that, ultimately the UF filter, so this is the UF filter, so output of this will go into the tank. Okay, and you see this clamp, so this is to tie two candles together. For example, I'll put this candle here and then put this clamp on top of this. Now here I can place one more candle. Okay, so this is just to put things together. So this is alignment in my RO. In your case it can be a little different. Just observe how it is and you have to repeat the same thing while assembling. Okay, so this is another RO in our house. I just opened the front panel, the top panel, to show you the RO inside. So you can see this is UF filter and this is the last filter, last filtration stage. Output of this guy directly goes into the tank. Okay, and this RO has one more additional filter, that is UV filter, ultraviolet filter, and as I told you, this requires current also. Other filters don't require current, but this guy requires current because there's a UV bulb inside to emit the UV rays to kill the bacteria. So this is the only guy in the candles filters which requires electricity, and booster pump and SV requires electricity. Okay, so this is how it looks. And let's say if you want to start the assembling or disassembling, what you have to do, take the screenshot or take a video. What is the flow of water, how they are put together, how they are connected. Okay, while assembling, that will help you. Okay, disassembling is very easy. Start from any filter, pull this out, pull these connectors, these pipe, pull this one out, pull this one out. This one you cannot take it out because it has a wire, so it has to be managed while keeping there itself. Okay, and this doesn't require replacement, by the way, because it's not filtering anything. It has only UV bulb. If the bulb is gone, then we have to replace this. Otherwise it doesn't require replacement. Other candles require replacement. So that's it for this video. If you like this content, please hit the like button and do subscribe my channel for more such videos on house maintenance. Thank you.